Thank you very much. And I would like to have my slides, if possible. So first of all, President Joachim von Braun and Marcelo, good to see you again. And also Cardinal Turkson and Roberto, thank you very much for inviting us here to be with you on this important topic. And what I would like to talk to you about is the impact on climate change on the ocean. I put the S in brackets, and it's a wonderful setting to discuss that with you. And the reason why I put the S in brackets is if you look at the ocean from that perspective, from that map's perspective, I think it makes it very clear that we have one ocean, which is very much connected. When the ocean comes with the S, I have the feeling we have many of them. Maybe we can kill one and save the other. That's not the case. There's one ocean and one planet and one humanity that goes around. And there's no surprise that faith-based organizations like this one are actually kind of interested in that. Now, when you take a look at this topic from a sort of popular press point of view, extreme sea levels are going to increase in Australia. Faster pace of climate change is scary. We have most of the Earth is very close to melting conditions. Empty nets in tropical fish in Tasmania. So full of headline news on climate and climate change on the ocean. Extreme weather caused climate change and damaged 45% of Australia's coral habitat. And climate emergency and food crisis looms. Here's why the ocean could be the solution, an intervention from actually yesterday. So it's all over increasingly the popular press, in the political agenda, and actually in thanks part to academies, our ocean friends, it's more and more also in the policy agenda. And this year, some call of the Year of the Ocean with the UN Ocean Conference in Lisbon, that was just mentioned by Joachim, coming up, and many other conferences in the climate arena as well. But let me start, why do we know what we know? So I'm going to go back to Anton Dohrn here as an example. And I have three pictures here, the way which Anton Dohrn and the colleagues around him at the time were working. They were looking at the ocean, sampling it, looking at the biodiversity, and writing it down, purely to understand what's out there. I don't think they had any concept of climate change at that point. Biodiversity loss was not a concept at all. But academies, academicians around the world sampled that. Today, the lower picture shows you a wide range of effects that we have from satellites, ships, robots, that can actually sample the ocean in much modern ways. Now, what did you do when you have that information? At the time of Anton Dohrn, publications like the one I'm showing here, the Zoologische Jahresbericht von 1911, obviously in German, because at that time, German was the language of science. Now we publish in English, and the latest report on the ocean is the Ocean State Report from last year. So we've really come a long way between the times of Anton Dohrn and what we can do today. Jeffrey, you should be sitting here, next to me. So, but taking that, how we get the ocean changes more professionally done through the academic work, we have the Intergovernmental Panel of Climate Change that takes the work from the World Climate Research Program. We have the International Platform on Biodiversity and Ecosystem Sciences. We have the World Ocean Assessment. So we have professional organizations that take the science from all the academicians around the world and putting these reports out. I think these reports provide trust, their reliability, and give us good information. And certainly there has been one on looking at the ocean and the cryosphere just 2 years ago, and you can find some of the graphs and documentations here. And I won't speak about all of them. I'm just going to give you one or two of the highlights. So we came a long way between Anton Dohrn's times and today's time, and actually knowing what we know and how certain we are about that. And I think these are really the basis upon which policy decisions should be taken, which is also the basis of our report that we're producing here. IPBES looks at biodiversity. If you look at their signals, biodiversity is down, not my topic here. I'm sure Lisa will mention a few words about that. The World Ocean Assessment takes also regional approaches and looks at how the ocean and the sustainability of life in the ocean, but also communities live off the ocean, is affected. So lots of documentation showing us about the state of the ocean and how it's changing. So what are the highlights on the ocean and climate agenda? So the ocean plays a central role in regulating the Earth's climate system. It moves an enormous amount of heat from the tropics to the poles. It holds a lot of fresh water, obviously, but it also has taken up 90% of the heat of planetary warming, global warming. It also takes up about 25% of the extra CO2 that is the cause of global warming, but its effect I've been seeing, the ocean is heating up, sea level is rising, it's losing oxygen, and things around that. Obviously, the biodiversity is threatened as well. So I'm going to pick just two examples. Heat. This graph on the left shows you the energy in the ocean. That's equivalent to temperature, but it's actually averaged over the upper 2 kilometers, and it's a very clear signal. Unlike the temperature in the atmosphere, which is noisy, the energy of the ocean is very clear. And I think you can clearly see how over the last 50 or 80 years, the planet has been warming. 90% of the heat is taken up by the ocean. It's the most clear evidence of climate change that we find on the planet, and it's the cornerstone of IPCC reports. There is no doubt that this is happening. Second, what does it do? It means a warming ocean, like a warming air, expands, and also melting glaciers contribute to that, and the sea level is rising. Since Anton Dorn's time and our time, the sea level has been risen by 20 centimeters. That doesn't sound like a lot in the face of tides and all of that, but if you live in a tropical island, that is very noticeable, and some of the Mediterranean regions as well. But that is what the diagnostic is. It's very clear, it's very well understood, 20% today, but what does the future hold? So the Intergovernmental Panel for Climate Change says sea level rise will continue. You see two curves. The blue curve is pretty much net zero carbon dioxide. It's the most ambitious climate mitigation that we can imagine, which still means at the end of the century, we're gonna have double of that what we have. Half a meter, 60 centimeters is an unavoidable sea level rise. If we don't stop emissions, if we keep on going what we're doing today, we'll have a meter at the end of the century. So the difference is between half a meter and a meter. But it won't stop then. The last IPCC goes on and says a century or two out, we'll have 3 or 4 meters of sea level rise, at least 1 meter committed, 2 or 3 possible, depending on fossil fuel emissions. So it's probably one of the most toughest thing to adapt against, given that 90% of the trade around the planet is on ships, which come into ports, and ports will have a hard time dealing with a meter sea level rise. Almost all port infrastructures around the globe have to be reimagined and rebuilt. I'm going to pick another topic, which is extremes. Extremes are about flooding, heat waves, low oxygen event, algae blooms, and I'm just going to focus on one of them, that is heat waves. So what are heat waves? Heat waves today, I think we had a very hot day in Rome yesterday, so we're very accustomed to heat waves on our land-based systems, but they can also happen in the ocean. They happen in certain regions of the ocean, not globally, and they can be 1 degree, 2 degrees, 3 degrees centigrade warmer. Sometimes we call them the blob. So these heat waves have been increasing quite a bit over the last 50 years, very noticeable, and the expectation, again, blue and red curve, is that they're going to grow even more, even under the toughest mitigation scenarios. We're going to see at least 30% more heat waves and double of the number of heat waves or more with unabated climate change. Now, what is interesting science on the last 3 years, that if you know a bit of a mathematician on land, there's a PDF of how these heat waves happen that will shift a bit, so it'll become more likely. In the ocean, the shift is smaller, but it comes completely out of the range of normal. That means marine organisms will be affected by heat waves in ways that they have never seen before. That's why we are seeing this devastating effect on coral reefs, on tropical fish, because it's outside of the normal. This is much worse than heat waves on land in the ocean. This is science which is only 4 or 5 years old. Very warning in some sense. So, and what heat waves do in the ocean, they shift, for example, from a kelp forest type of ecosystem to a seaweed turp type of ecosystem. And quite often, once a heat wave strikes, the system flips to a new state and stays there. It doesn't come back. So these extreme events give us change that is unreversible, even if heat waves don't occur anymore. We've seen it in coral systems. We've seen it in some of these seagrass systems and seaweed systems. So it's a very concerning additional threat to the ones that we're more familiar with. We heard about oxygen. Here's some work from our own team where we looked at the global balance of dissolved oxygen in the ocean. So that is important for, let's say, big fish who breathe the ocean. And that has dropped by 2% over the last 50 years That doesn't sound much, but there's some parts in the ocean where oxygen is already scarce. That reduction is more there, and means these are uninhabitable by fish and other organism takes over, and we call them dead zones in the Mediterranean, coastal communities in the Baltic and other parts of the world. These dead zones are expanding. Why are they called dead zones? Because fish can't survive and microorganisms take over. It's a different ecosystem, not so supportive for us as humans. So, but on the one hand, we know something about the ocean, but we're still in the phase of discovery. I'm showing just a deep sea organism that Lisa will show many more pictures of, which I think are much more beautiful. But on the left-hand side, I'm just showing a particular circulation system on the Atlantic Ocean from data points that were taken last month by my colleague, trying to understand how the circulation in the tropics work. We are still discovering new circulation regimes in the deep ocean that we haven't seen a decade ago. So in the ocean, we're still in the discovery phase. We haven't fully understood the system just yet. Although in general, I think the science and the ocean science about its understanding of human pressures, Roberto mentioned a few of those. Plastic was mentioned also by Joachim. And many people look at us and say, Martin, stop. It's one bad news story after the other. Can't scientists do something more productive than telling us how bad it is, how much pressures there are? Yes, we can. So that's what we do. But we're also doing science about resilience. What can we do about the system to support resilience? And I think it's exciting science that happens around the world, but sometimes not spoken much so often because the pressures are more pressed and noteworthy. I think it's very important science. At the end of the day, what we're trying to do is really to get to prosperity, a regime where we can take advantage of the ecosystem service or the contribution to humans that oceans offer to us. I think that is what academies around the world are striving for. It's the combination of pressures that we want to mitigate and resilience that we want to promote. So, and that's no surprise that that agenda about transformation, Jeffrey is next to me, the world in 2050, has given some of these transformations for the total system. Some of them relate directly to where the ocean is. And in the ocean, we take that agenda forward in what we call the UN Decade of Ocean Science for Sustainable Development. The vision of that decade is the science that we need for the ocean that we want. And Jeffrey, it's the ocean that we want for the future that we're looking forward to. There's an ocean contribution to that. And obviously it's about transforming the science that we do and really connecting that science to the needs of people. And let me give you a short video of what this decade is all about. It's from the opening from last year that happened in virtual Berlin.
The ocean acts as a climate machine, economic space, and a source of food for many, many people around the globe. And I would like to invite all of you to join us for a dive into the unknown secrets of the ocean.
Die Zukunft unserer Erde,
The future of our Earth thus heavily depends on how we treat our oceans. Germany has proved itself to be a competent and reliable partner in this field.
We need to start living in harmony with the ocean.
It is time for a revolution in ocean science. And this revolution now has a name, the United Nations Decade of Ocean Science for Sustainable Development. Together, let us discover the science we need for the ocean we want.
This decade offers a unique opportunity, a clear framework for action by better coordinating global efforts.
We are very much aware that to reach our European Green Deal ambitions and make Europe a climate-neutral continent by 2050, we need healthy oceans.
The agreed ambition of the G7 to tackle climate change, which of course is such a stressor on the ocean system.
The ocean is our future.
It's become increasingly obvious that ocean science must be the foundation upon which the achievement of SDG 14 is built.
I can tell you that we do not have time. We have to act now.
There's a lot of traditional knowledge in our region built up over millennia that we could make use of in the global science community.
You have to think 7 generations ahead.
And this is reserved through a process which they call Raui. So in certain places, when they fish, for example, on the reef itself, there is a section that they have to block, which is taboo, that no one's touched it.
We need international organizations and we need the willingness to protect us from illegal fishing. While we are trying to find solutions for a different future, for a different ocean, we have to learn to be resilient, to adapt to the things to come.
It needs to be part of our jobs to think about partnerships.
You know, for us, it's about transforming the industries as they are now into a sustainable future.
I think this next generation is ready to take on this challenge, especially if the international community does what the Ocean Decade is doing here today.
I think that we need to improve the way we communicate science to the general public.
From around the world about the importance of the ocean. And so what is the decade all about? It has 10 challenges. It's about understanding land-sea-based source of pollutants. We talked about that. Solution to protect, monitor, manage, and restore ecosystem and their biodiversity, sustainably feeding the world's population, equitable and sustainable development of the ocean economy. I think topics we already touched upon. The fifth channel is the topic of my talk, is understanding the ocean and climate nexus. I gave you some ideas about that. Expanding multi-hazard warning systems in the ocean, a sustainable ocean observing system, a digital representation of the ocean. I'll make a few remarks in a moment on that one. Capacity development, equitable access to data, information, knowledge, and technology. I think a very important part where I think the Papal Academy is a global academy that really helps to lift up all of the world to the same level of information. And last but not least, to understand what are the barriers to behavioral change and what can we do about that. That is a very important topic, but I also think this academy is thinking about barriers of to the transformation that we need to do. So I'm going to just close by making a couple of remarks on digital opportunities. Climate change, loss of biodiversity, the blue economy, I think they can be tackled with what we call digital twins of the ocean. So what are digital twins of the ocean? They take the observation that we have through the lens of data and models and produce the knowledge that we need to inform sustainable development. So they're a digital framework where all the data come together and allow us to produce a virtual ocean. Take the real ocean, take a virtual ocean. And in the virtual ocean, you want to do the experimentation. You want to take Jeffrey Sachs' transformative solution and see, can they work in the virtual space before they do them in the real space? It's an engineering tool for optimizing outcomes. It's for answering what-if questions. To make it very practical, if you want to defend yourself against sea level rise, you have the options to build a dike, you have the options to build sandbars, you can regrow mangrove forests or coral reefs depending on where you are, or you can retreat. So the question in your coastal community is, what is my best shot? And the way you do that is you take the global scenarios for sea level rise, you regionalize them to your region, you experiment digitally and say, what if I put dikes out there? Or what combination gives the best solution for adaptation, given that mitigation is only going so far? So digital twins are really a framework of intervention, of action, of optimizing outcomes, of answering what-if questions. And I think you're going to hear a whole lot more about that as a tool to future-proof sustainable development options. And I think it's a very exciting space that we're entering in. So colleagues, I'm going to leave you with some thoughts in my last minute and 25 seconds. I think it's ocean health that we talk about a lot. What do we mean by that? We mean an ocean that supports or that provides contributions to humanity in that new sense of IPBES. So what are the nature's contribution to people? What are the ocean's contribution to humanity in coastal zones, but also afar? And the question is, an unhealthy ocean is an ocean that can only have limited of these contributions. So that's what we might mean by ocean health in this sustainability sense. And climate is threatening that. Climate change by sea level rise, by warming, by stresses on ecosystems, loss of oxygen, and the like. On the other hand, we're talking about healthy ecosystem, animal health, plant health, right? So that is the contributions to that. And at the end of the day, it's about our own health, not only directly speaking, but as a healthy community, as a healthy society. So this One Health concept directly relates to what we need to do. And what do we need to do is inform sustainable development options. Clearly on the climate side, it's the net zero. It's the reduction of carbon dioxide. It's coming to a net zero regime because I showed you what the blue options were already difficult and the red options, which are almost impossible for future generations to manage. I'm looking at our representative of the next generation here. So clearly there's opportunities for us to inform development, to use the ocean smartly and sustainably, and to really bring together from an academic point of view, the ocean threats and the ocean use to a happy, sustainable development. I think it's an exciting agenda, it's an inspiring agenda, and a lot of work for us to do. The next generation, all of society, academies around the world, thank you for listening.
So thank you, Professor Martin, for your input. And briefly, are there any quick reaction, question or so within the next 5 or so minutes? Anybody has an input, a small question or something to put?
So thank you very much, Martin, because that was really inspiring. And the point is that according to the models and the prediction we have different scenarios in which, however, these conditions will continue to move on. The point is, in your opinion, do we have technological solutions or solutions that are apart the mitigation of global climate change, which is the problem? But do we have something, can we do something more than that, even though we don't do enough for that from that point of view?
So I didn't speak about that. I do think dealing with environmental change and climate change needs all approaches that we have, right? On the one hand, I think it's clear that mitigation should be the primary target, that is reducing the CO2 emissions. But second of that is adaptation is then the must. We have to adapt to what we have committed already and maybe more. So that's clear, but is there anything in between? And there are some things in between. For example, the ocean is taking up quite a bit of carbon. Question is, do we want to encourage the ocean by intervention to take up more CO2, so to become more of a sink? This is what we call climate interventions, climate engineering, geoengineering, you pick your word. There's a lot of science in the academies around that. Technology-wise, it is probably possible. The amounts of olivine or, let's say, nutrients you have to move around are staggering, but not impossible to do. The side effects are probably large. So as we academics, we study that, you can ask the question, is it desirable? Probably not. Is it feasible? Maybe. Economically? Possibly. Is there a social contract behind it? Very much debatable. I think that's the third best option. It's not that we cannot do it, we probably could, but it's not so clear that we want to do it. And I think these digital twins that I mentioned will give us an opportunity to study that, because if you put olivine in the ocean as an example to take up more CO2, your ecosystem will react dramatically to that. It's probably also going to be heavy metal pollution, so the side effects are big. So maybe we're going to go that way, but we have to think about that very carefully. So my answer is, we need to do all the solutions, technology, behavioral change, transformation. There's no silver bullet here, and we have to look at all of them. And I think academies in particular's job it is to look at the whole range and say what's feasible, desirable, and doable.
Okay. So, Prof. Martin, your science agenda is very convincing. I wonder how to get it implemented. And don't we need new mechanisms of bringing the bodies that do parts of this science together? And how about including low-income countries more in this partly fairly expensive science? So don't we need some sort of consultative group mechanisms on ocean science?
Well, thank you very much, Joachim, for that question. If the UN Decade of Ocean Science for Sustainable Development, if you're part of the discussion that we're having there, it's all about that. Because the majority of the countries that are part of the UN are not the G7, which are rich, which are almost all of us here, which are the ones who are in need of information or in need of trying to understand their own ocean system and who want to contribute to that agenda. They actually have a lot of knowledge to offer. They have insights in their own system. But I think it's our joint responsibility, let's say, to allow that to happen. So what does that mean very practically? It means countries like the United States, like Germany, to really work in partnerships with countries of the global south. I can speak for Germany, for my own institution, GEOMAR. We have a very close partnership with the Cabo Verde Islands. We operate a joint science center there. And the science center is really run and owned half by the Cabo Verdeans, and they use that science center to advance their own science, their own ambition, their own colleagues from the region, and to bring to us and with them the agendas of sustainable development, of protecting biodiversity and fisheries. So Joachim, yes, we need mechanisms to really support all of us on the planet to exchange our knowledge and to lift up those who don't have the same technology means that we have. And there's quite a few programs out there. More could be done. It's on the agenda for the G7. I'll be speaking to the science ministers next week, but it's also on the agenda of the decade. So I think in Lisbon, you hear a lot about that, these transfer mechanisms of technology, but also allowing them to access our capabilities. Maybe Lisa will mention how they're doing it, but it's very much up on our hearts to really make sure that becomes an inclusive operation that also includes civil society, the private sector, and academicians.
Thank you. Yes, Jeffrey. Yeah.
Thank you very much. And I can tell you in 21 years, every time I had a question on oceans, I asked Martin. So, and he's always been right. So it's been a good long run. Of the UN treaties, the UN Law of the Sea, CBD, Convention on Biological Diversity, Framework Convention on Climate Change, and others, are any of them really helpful for the oceans, or are the oceans treated tangentially in all of them, just as a very operational governance point of view?
Thanks you, Jeffrey, for that question. Clearly, the Law of the Sea is being the most significant work the UN has ever done, actually, in terms of governing board. It's the premier framework within which we operate. The Law of the Sea is extremely helpful because it regulates these spaces. And Cardinal, you mentioned that common heritage of mankind, which is enshrined in the Law of the Sea, but only for the seafloor. I wish it was also true for the wet part of the ocean where the fish and the ecosystem is. But what we've seen, for example, Jeffrey, that at the time when the Law of the Sea passed all the resolutions at the General Assembly, no proviso was made for actually marine protected areas. And this is why the BB&J discussions are ongoing and almost finished, that it would allow to actually designate a certain part of what we call the high seas to be a marine protected area. Legally speaking, it's not possible right now because that frame isn't allowing for that. The Seabed Authority, which regulates access to the deep sea, is a useful organization because it has some provisos around it. But I will say that ocean governance is piecemeal across the UN. The Law of the Sea sort of has the premier role, I would say, but it's not all of them are fully aligned with sustainable development just yet. They're more sectorial that we see in all of them. But I do think that the UN Ocean Conferences give an opportunity and an ambition to revive maybe what was called the UN Ocean Group that takes together all the expert agency and really brings sustainable development and the ocean dimension of that to the fore. Can this be successfully done? We'll have to see. But ocean governance is, I think, the one arena, Jeffrey, you've seen where multilateralism is still strong. We're seeing it walking away from multilateralism in many other parts. But in ocean, it's strong because every coastal state understands what I do is not the only thing that matters to my own ecosystem, it's also what the neighbors do. So only global solution will help you to even safeguard or protect or develop your own region. So that recognition is very clear in ocean. That's why multilateral approaches are the only way to do it. And I think it gives us motivation to take that ocean example to the climate arena, to the biodiversity arena, to really make the point that that's not just true for the ocean, but for everything else. So in that sense, yes, it's a bit of a poster child, but it's also neglected because we live on land, it's a little bit farther away, and ocean governance is a bit piecemeal. The Law of the Sea could regulate it, but we're still fighting in certain silos, and it's not fully integrated just yet.